Hi guys, how are you? This is Ali from Medicine Made Easy. Thank you for checking my YouTube. Today we will talk about um, major electrolytes. Some of the electrolytes, sodium, calcium, and potassium, we have a measured value and corrected value. The measured value is the value we found on a blood sample that we receive from the lab. The corrected value is the value that we have to measure. Why we do that and how we do that, we will get into it. Let's start with the corrected sodium. You know guys very well what affects the level of sodium in the body is the level of water, but also level of sugar affect the level of sodium. When there is a high level of sugar, the level of sodium goes down, and that's what we found on the measured level of sodium from the blood sample. But we need to measure the corrected level of sodium, which means the level of sodium without the effect of high blood sugar. That's why always the level of corrected sodium is higher than the level of measured sodium. The corrected level of sodium, how we found it, is the measured level of sodium plus the glucose level minus 100 times 0.016. So why 100? What is 100? What is that number? Where is it coming from? 100 is the normal level of blood sugar, represented by 100. Why we put 0.016? They found that every 100 increase in the level of blood sugar will lead to a decrease in the level of sodium. How much? Every 100 increase in the level of sugar cause 1.6 millimole per liter 1.6 millimole per liter decrease in the level of sodium. That's why we have to add 0.016 multiplied by the difference in the blood sugar. Let's take an example. Measured sodium, for example, 132 millimole per liter. What is the normal level of blood sodium? The normal level is 135 to 145. And the level of blood glucose is 500 milligram per deciliter. So the corrected level of sodium will be 132 plus 500 minus 100, which is 400, times 0.016, or 4 times 1.6. So the result will be 132 plus 6.4, which is equal to 138.4 millimole per liter. Look guys how big the difference between the corrected level of sodium and the measured level. The measured level was 132. This is hyponatremia. But the corrected level of sodium is 138.4. This is normal. As we said before, normal level of sodium is 135 to 145. This will make a big difference when we want to treat hyponatremia. Let's move to corrected calcium. Why we need to measure the level of calcium corrected one? How many types of calcium in the body? We have ionized, which is non-bound or free, which is the active form, and we have calcium that is bound to anions in the form of salts, as you know. And also we have a calcium that is bound to protein, which is albumin. So the level of albumin, when it goes down, the level of calcium will go down. Okay, guys? And this is in the measured calcium. So we will need to measure the level of calcium that's without the effect of low albumin. This is called the corrected level of calcium. As simple as that. So the corrected level of calcium is the serum calcium, the measured calcium that we receive from the lab, plus 0.8 times 4 minus serum albumin. So why number 4? What is number 4 came from? Number 4 is the normal level of albumin, which is actually 3.4 to 5.4. As an average, we put 4. Make it easy. For example, let's take an example. Measured calcium, if it is 7.2, which is low, what is the normal level of calcium, guys? It is 8.5 to 10.5. So here the measured calcium is 7.2, hypocalcemia, milligram per deciliter, and the measured serum albumin is 2 grams per deciliter. Very low, hypoalbuminemia. So the corrected calcium will be what? Will be 7.2 plus 0.8 times 4 minus 2, which is 2. So 2 times 2 times 0.8 is what? Is 1.6. 1.6 plus 7.2, the corrected level of calcium will be 8.8. Big difference. 8.8 is the corrected one, while the measured one was 7.2. Big difference. So from the difference in the numbers of the measured one and the corrected one, you can tell, guys, that the corrected value need to be calculated. And as we see so far, sodium and calcium, the level of corrected value is higher than the measured one. Now we move to potassium. Potassium is a different story. Potassium, the level of corrected potassium is lower than the measured one. Why is that? It is different than sodium and calcium. We will see. Why we need to measure the corrected potassium. Potassium gets affected by the level of pH, the acidity. When the pH goes down, that means the blood is more acidic, the level of potassium goes up. So we need to measure the level of potassium without the effect of the acidity, which is the corrected level of potassium, which is always lower than the level of measured potassium, because when the pH goes down, potassium goes up. The corrected potassium is the measured potassium that we receive from the lab minus 0.6 times the initial pH minus the final pH divided by 0.1. So first we need to measure the difference in the pH. What is the initial pH? We always put in the equation 7.4, which is the normal level of blood pH. Neutral one, 7.35 to 7.45. As an average, we put 7.4 in the initial pH. What is the final pH? The pH that we receive from the lab. We find the difference, we divide it by 0.1, and then we multiply this by 0.6. What is 0.6 and what is 0.1? Why we get those numbers in the equation? They found that every drop in the pH, every 0.1 drop in the pH will make an increase in the potassium 0.6. That's why we put those numbers in the equation. Makes sense, huh? For example, always the example make it easy to understand. The measured potassium is, for example, 5.8. This is hyperkalemia. What is the normal level of potassium? 3.5 to 5.3 milliequivalent per liter. And the final pH, 7.2. This is acidic. So we have acidosis and we have hyperkalemia in the measured level of potassium. What about the corrected one? The corrected potassium will be 5.8 minus 0.6 times 7.4 minus 7.2 divided by 0.1. So 7.4 minus 7.2, this is 0.2. Divided by 0.1, that's equal to 2. 2 times 0.6, this is 1.2. 5.8 minus 1.2 equal to 4.6 milliequivalent per liter. Big difference. 5.8 is hyperkalemia. 4.6 normal potassium. So this will make a big difference when you want to treat a patient. Always put this in your mind. For sodium and calcium, the corrected value is higher than the measured value. But for potassium, the opposite. The corrected value is lower than the measured value. Thank you guys for watching my YouTube. I really appreciate your support. Please subscribe, like, and share. If you have any comment or question, please let me know. Any mistake in the YouTubes, in this YouTube or other YouTubes, please let me know. I apologize for that. The whole story is if I know something, I will share it with you guys. So we will teach each other. Thank you again for watching. This is Ali from Medicine Made Easy. Good luck in everything. Bye now.